Good morning. Hope everybody's doing well. We're going to go ahead and start circles today. If anybody still needed to go through and take the test or do any of the other assignments, they're all still open. I'm going to try to make this quick. I don't want you guys to have to sit through a 30 or 40-minute video. So we're going to go ahead and talk about circles in the coordinate plane today. We'll go ahead and do 3 or 4 examples. There's a homework assignment posted on Pearson for you guys that you guys can start working on. And then I want you guys to go ahead and have a chance to watch this video, start working. So we'll go ahead and we'll do another meeting tomorrow at 11 a.m. Okay. Remember, meetings are if you guys have questions about things that are going on, it could be on the video or just school in general. Okay.
So we're going to go ahead and jump into
circles here. So we're going to go ahead and talk about them in a coordinate plane first. So right now we're talking about the graphs of circles, the equations of circles, stuff like that. After this section, we're going to go ahead and talk about it in more of a geometric perspective. But being able to know the equations and things like that are going to come up next year a couple of times. So when we're talking about graphing circles, the equation of a circle is written this way. So when we're talking about the equation of a circle, we write it this way. It says x minus h squared plus y minus k squared equals r squared. H and k are going to have values just like when we graph parabolas. H and k, the way you guys can think about them, again, they're shifts. So the x shift is going to go left and right. The y shift is going to go up and down. And then we'll talk about that in a minute. So when we define these, we actually define the point hk. You know what? Actually, let me go ahead and do it this way. I'm just changing colors, so don't worry about erasing anything. And then let's go ahead and make R that purple. So when we're looking at the point, we're talking about the equation h comma k, and if you guys can hear my kids, I'm sorry, they're downstairs playing. H comma k is the center of the circle. So when we graph h comma k is going to be the point in the middle, that's the center. R is going to be your radius. So one thing that we have to note when we look at the equation, these signs are opposites. So these are minuses here. So if you had an equation like x minus 1 squared plus y minus 3 squared, the center is actually going to be at 1, 3. So it's always going to be at the opposite of whatever's in there because they're negative. The other thing you guys have to pay attention to is the r is squared in the equation. So we have to take the square root to go back if we're going to graph it. If they give you a graph or something, we're going to have to square it to go back to the equation. Sorry. So we're going to go through what we do with circles, really, guys. We look at the equations, we identify the centers, we figure out how to sketch them, and there's a couple of things that we can do with them, identifying if points and things are on there. We're not going to go too far in depth with them. So you guys should know this equation. This equation is important. It'll show up in homework. It'll show up when we take the last quiz for circles, okay? So one thing that we can do with this is we can go through and we can use this to identify the center and radius. So some of your homework problems will look like this. It's going to say identify the center and radius of the circle. Oop. So those are going to be the examples. There will be a few problems like that, and they're going to give us equations. So let's look at one this way. Let's look at the equation x minus 3 squared plus, and that's always going to be a plus in the middle, guys. You'll never have to worry about changing that. Y plus 4 squared equals 25. Now, when we're trying to find the center, they want us to identify the center and the radius. So the center is going to show up in the equation. The center is going to show up here and here. And we're going to remember that they're always the opposites. So it's x minus h. So when you say x minus 3, our h is actually 3. So when we're trying to find the center, remember, we always want the opposite of whatever's in here. If it's negative, we want positive. If it's positive, we want negative. So when you had x minus 3, that means the right shift, the right-left shift is going to be 3 to the right. So that's your positive 3. The plus 4 is going to become negative 4. So that's going to move down. So your center of that circle is going to be at 3, negative 4. And then when we want to go through and we want to find the radius of that circle, this number over here, let's go ahead and change our colors. Oop, missed it. This number over here, that's r squared. So if I want to go through and I want to find r, so 25 is equal to r squared. So if I wanted to go through and solve for r, if I know r squared equals 25, I can take the square root of both sides to get rid of this squared. And then I find out that r is just 5. So identifying the center and the radius isn't that bad. The center of the circle is at 3, -4. The radius is 5. So if they just ask you to find that, we can find it. If they ask you to graph the circle. So now let's take that a step further and let's go ahead and let's graph it. And we're just going to sketch it. Okay, guys, we're not going to worry about our graph being perfect, but we're going to go ahead and we're going to look at a sketch. So I want to go ahead and draw my coordinate axis here. So I'm going to put it right there and move it up here a little bit so it's out of the way. Let's go ahead and scale that really quick. Our radius is 5, so we're going to have to move 5 units away from all of these. So we're going to have to move 5 units to the right and the left of 3 and 5 units up and down of -4. So when I scale this, I'm actually going to put quite a few points on here. Let's go to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 10. So that's not perfectly scaled, but that'll work for what we're doing. We've got x, we've got f of x. So when we go through and we graph this, the first thing you guys are going to do, oops, sorry guys, hit the wrong button. First thing you guys are going to do, you guys are going to plot the center. To figure out where the center of our circle is. It's at that point 3, -4. So 3, -4, you guys are going to go right 3. 1, 2, 3. You guys are going to go down 4. 1, 2, 3, 4. So that point right there, 3, -4. That's also our center, okay? After you guys go through and you plot the center, all you guys have to do to sketch a graph of the circle. Again, if we wanted to find more points and make this a perfect circle, you're going to have to do some more work. We're not going to deal with that because we're not in this class. I want you guys to go up, down, left, and right, R units. When I say R units, I mean the radius. So in this case, our radius is 5. So I want to go 5 to the right and left, 5 up and down. So from right here, I'm going 1, 2, 3, 4, 5. I'm going to put a point right there. We go down 5. 1, 2, 3, 4, 5. I'm going to put a point right there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And now if I'm drawing this by hand, guys, I'm going to go ahead and I'm just going to draw a circle through all of these. I kind of, for fun, want to try this and see how it works. So I'm going to center it right there. Yeah, that didn't work. Hold on one second. Let me move that one way over the side here. What if I start it? Oh, that didn't work either. Okay, I'm not going to mess around with this. We're going to waste a ton of time in the video. So what I want you guys to do from here, come around and plot a circle. If we were in school, I'd show you guys how to use your arm to do it with the board and all that kind of stuff. But so from an equation, we can go through, we can identify the center and the radius, and then we can graph it. Now we're going to go through and let's look at one or two more of them. When we do these next couple, go ahead. I'm going to write the problem out. You guys go through and do it really quick. And just like we did before, go ahead, jump forward in the video. If everything looks the same, you guys can move ahead. You guys don't have to listen to the explanations, okay? So we're going to do the same thing on the second one. Second one here, we're going to go ahead and do x plus 2 squared plus y squared equals 9. So I want you guys to find the center and the radius and graph it. So go ahead and do that. I'm going to give you guys a second to pause. And now we'll talk about it. Okay, so the center of this is at h comma k. So remember, h comma k is always the opposite of whatever's in here with x and y. So the opposite of positive 2 is negative 2. When we're talking here about this y squared, there is no value in here. So if there is no value in there, there's a certain number we're adding and subtracting to y before we square it. That number is actually 0. So when there's nothing there, guys, it's going to go through and it's just going to be 0. If you were looking at a circle x squared plus y squared, that's centered at the origin. And we'll look at one of those in a minute. So our center here is negative 2, 0. Our radius is the square root of 9, which is 3. So this circle's centered at negative 2, 0. It's got a radius of 3. I'm going to go ahead and just draw it this time, guys, even though it's probably going to end up bad. So we're going to go ahead and draw, so mine will look a little more like yours. X, f of x. Now we're going to have to go at negative 2 and move 3 units, so let's go to 5 or 6 on each side. 2, 3, 4, 5, 6. 2, 3, 4. 1, 2, 3, 4, 5, 6. So let's plot the center first. Our center is going to be here at, and the better you scale your graphs, the more circular your graph will look when you guys make it. I'm going pretty quick here, so this is probably not going to be perfect. Center's at negative 2, 0. So we move 2 to the left. We don't move up or down at all. Radius is 3, so I want you guys to go 3 to the left, 3 to the right, 3 up, 3 down, and we got a circle. That's a really bad, poorly drawn circle, but that's okay. So again, we can identify the center and the radius based on the equation, and we can go through and we can sketch a graph pretty quickly. All right, so sometimes, and these are the problems that I actually really like. I'm not even sure if there's any of them in your homework. I think one of them showed up. Expect that when you guys take a test or a quiz on this, I will definitely find a way to make sure one of these is in there, because this brings something back from first semester. So let's look at something like this. What if the equation wasn't in that form? What if the equation looked like x squared plus y squared minus 6x plus 8x plus 16 equals 0? So that's a mess, right? It doesn't look anything like what we've got up here. This x minus h squared plus this y minus k squared equals r squared. We need to go through and figure out a way that I can make this thing down here look like this thing up here. Hopefully you guys remember from first semester completing the square. So if you guys don't remember, I'm going to go through this really quick. If we had something like x squared plus 6x, and we wanted to figure out, hey, what number needs to go here to make that a perfect square, we did it a couple of different ways. We went ahead and we drew this square that looked like this, so we divided it up into those 4 parts. We knew to get our x squared, we had to have x by x. And remember, because this is a square, it has to be divided evenly. So we had to figure out, how am I going to split those 6 x's to get them here and here? Well, I'd have to have 3 of them in each. So I need 3x here and 3x here, which means I'm going to have plus 3 and plus 3. And then this number over here that I have to actually add to there comes from 3 times 3. So that's 9. So that's what I would have to add to here. And remember, we'd have to add it to the other side. So when we're going through and we're completing the square, we did this to graph parabolas earlier this year. When we're going through and we're doing something like that, and I'm going to leave this down here actually. We're going through, we're always taking that middle number, we divide it by 2 and square it, and then we remember to add it to both sides. Now this equation has x and y in it, so we're going to have to divide those up separately, but that's not a big deal. So first thing we need to do is we need to put the x's together. So x's are going to go together. My y, that should be a y on that second one. Sorry, guys. So I'm going to go through. I think I wrote 8x twice. I wrote minus 6x and then plus 8x. Let's fix that. So that should be a y. So plus 8y. And then this 16, we're going to have to get the heck out of there because we don't want to deal with it. So we're going to go ahead and we're going to move that to the other side. So we're going to regroup all our x's together. We're going to regroup all the y's together. We're going to move the constant. Okay. So regrouping x's, I've got x squared minus 6x. Regrouping y's, I've got y squared plus 8y. And to move this 16 to the other side of the equation, I've got to do the opposite. So that's going to give me a negative 16. A lot of times somebody will look at this and go, oh my God, no, I can't get a negative radius, but that's not a big deal because we're going to add numbers when we complete the square, okay? So we're going to have to go through and complete the square on both of these and figure out, add the number to both sides, and then we're going to rewrite it as a perfect square. So basically what we've got now is we've got the x squared minus 6x. We're going to add something here. Plus, we've got the y squared plus 8y here. And then we're going to add something there to make that a perfect square. That's going to equal the negative 16. And then we're going to have to add both those values to the other side there. Okay. So we're going to go through and complete the square here. Half of 6. And let's go and draw the diagram just in case you guys need it. I know towards the end nobody liked it, but we had our x squared. To divide that negative 6x, I had to have negative 3x and negative 3x. 3 times 3 gave us 9. So this 9 that we're adding here to make a perfect square goes up into that one. And if you notice, again, we took this negative 6, divided it by 2 to get negative 3, and then squared it. So if we use that same idea over here, 8y divided in half gives me 4y. 4y squared is going to give me 16. So we didn't even really have to use the box. I'm going to write it out just because we're going to have to rewrite these in a second. But that's a 4y. And there's a 4y to a 16. So this 9 also gets added there. This 16 also gets added there. So when we rewrite this left-hand side, I've got x minus 3 squared plus y plus 4 squared. Negative 16 plus 16, that makes 0. 0 plus 9 equals 9. So we took this equation, x squared plus y squared minus 6x plus 8y plus 16 equals 0, and we were able to rewrite it in this form, x minus h squared plus y minus k squared equals r squared. From there, I know the equation of the circle. I know the center of this circle is at 3, negative 4. I know the radius is the square root of 9, which is 3. If they give you guys a value, if they ask you in the homework, they say, hey, what's the square or what's the center and the radius of the circle? If they give you something at the end where you guys have a number that's not a perfect square, so you get something like 10 or 15, it's just the square root of 10 or the square root of 15. So if you guys can't get that, don't leave it as a perfect number or a exact value inside the square root rather than going through and turning it into a decimal unless they ask you guys to. I don't think there's any of these problems in the homework, but yeah, we're going to go through one in the meeting tomorrow. So we'll go through one of those, okay? Last thing that you guys are going to see in this section, and again, guys, this is really quick. If we were doing this in class, this would have been an entire block day that we would have gone through. We would have worked on the equation. We would have worked on graphing centers. You guys would have gone through and done homework, and then we probably would have came back, done completing the square, done that one along with what we're doing right now. So it would have been a couple of class periods. So I know this is going really fast. If it doesn't make sense the first time, we'll talk about it tomorrow, okay? So last thing that's going to show up is a point on the circle. So this actually goes back to things that we did with parabolas. You guys did it with lines last year. They're going to give you guys the equation of a circle, and they're going to give you guys a point. They're going to say, hey, is this point on the circle? And it's actually not too hard for us to go through and to figure out, okay? So what we're going to do here All right, sorry guys. One of my kids ran up really quick, so I had to go through and help them with something. So I paused really quick. Okay, so back to this. Our last question was: is a point on a circle? So when we're trying to go through and we're trying to determine that, the ones that we're going to look at, we're going to look at circles that are centered at the origin. So our first example is going to be the circle, and they're going to tell us it's centered at 0, 0. So it's centered at the point 0, 0, centered at the origin. Our circle is going to have a radius of 10. And then they're going to have us, they want to know, is the point -5 on the circle? So is that going to be one of the points that satisfies the equation that's actually on the circle? So in order to do that, we're going to have to write the equation. So we're going to have to go through, and if this thing's centered at 0, 0, it actually makes it a lot easier for us, because then our equation just looks like x squared plus y squared. Our radius here is going to be 10. So if our radius is 10, this is actually equal to r squared. So this is actually going to be equal to 100 when we look at the equation. X squared plus y squared equals 100. The center of that is going to be at h comma k. There is no h, there is no k, so both of those are going to be 0. And it's equal to r squared. So if you guys have 100 over here, the square root of 100 is 10. That's going to give us our radius is 10. Now, the nice thing about this is I know these are squared and all that, but going through and determining if a point's on a circle is the same as determining if a point's on a line, if a point's on a parabola, anything like that. All you have to do is plug in the point and see if it works. So if you guys were adding 3 or something here, we're going to have to go through and we're going to have to do that. I think all the ones in the homework are centered at the origin. So we're going to go through. I know our x value is -5. I know my y value is -5. So those are getting plugged in here. So you guys, again, with negatives, be careful with your calculators. If you don't put them in parentheses, it's not going to notice the negative. So when we're writing this out, I'm going to go ahead and write it in parentheses. This is -5 squared plus -5 squared equals 100. And we want to know, is that true? Well, -5 squared is 25. -5 squared is 25. Does that equal 100? 25 plus 25 is 50. Nah. That's not true. So 5, 5 is not on the circle, or -5, -5 is not on the circle. If you guys got a value that worked, then it would be on the circle. One more, because these are going to show up in the algebras a little bit different. Again, they're going to be centered at the origin. So let's look at another one, example B. Our center is again going to be 0, 0. This time, our radius is 7. And they gave us the point. They want to know, is this point on the circle? They gave us the point -3√2 and 5. So remember that -3√2, guys, that's just a number. Square root of 2 is like 1.41, I think, or something like that. So 1.41 times -3 is 1.4, 2.8, like 4.2. So -4.2 or something like that. I'm just trying to get the point through that the square root of 2 times -3, don't let that scare you. It's just a number. And we're going to have to go through and square it. Actually, written this way, it's easier algebra-wise. So again, let's go through and let's write the equation. X squared plus y squared, because we're centered at the origin, equals r squared. So if r is 7, then we're equal to 49. I want to know, is the x value -3√2 and the y value 5 going to end up working out to that? So let's go ahead and do -3√2 squared plus 5 squared. Is that equal to 49? When you square this, what we've really got is we've got -3√2 times -3√2. Now your calculators will do this, but it's actually not that bad. Square root of 2 times the square root of 2, we're just multiplying these numbers, but we're going to go ahead, we're going to put the radicals together. And with the arrows, don't get this mixed up with FOIL. I'm just trying to show you guys what's going together here. Square root of 2 times the square root of 2 is the square root of 4, which is just 2. -3 times -3 is +9. 9 times 2 is 18. Okay, so what we actually ended up doing there is we squared the number that was in front. So -3 squared is 9. We squared what was inside the square root, or we just got rid of the square root to make it a 2, and then we multiplied the two of those. So now I've got 18 5 squared is 25. I want to know, is that equal to 49? 25 plus 18 is 43. Is that equal to 49? No. So no, it's not on the circle. You guys will get values that are going to end up to being on the circle, okay? So I know I mentioned this before. I know I mention this every time. I'm sorry that these are so quick and that we go through everything so fast. Go ahead, watch through this, start to work on the homework, see what you guys can do with it. We'll go through and have a meeting tomorrow. So let's do a meeting at 11 o'clock. I'll send out a reminder to remind everybody about that. If you guys have any questions on any of this stuff, we can go ahead. We can talk about this. If you have any questions about what's going on, we can talk about that. I have to do your P5 or whatever those next grades are, the last one before the end of the year. So if you guys were right on the next grade level and you guys have been working and things like that, I'm going to go ahead and round you up. So if you were at a 69, I'll round it up to a 70. 59, I'd round it up to a 60, those kind of things. And then I'll give you guys the grade bump for doing all your work and your semester 2 grades, okay? I appreciate all of you guys sticking with me, and I appreciate everybody who sent a message last time when I sent one out and said, hey, sorry I haven't been doing the work, but there's a reason about it. I totally get it, guys. So do your best, go through, try to figure this out, and I will talk to everybody in the meeting tomorrow. All right? Have a good one.